Yes, hello. I'm going to do a video over 10.2, meaning radicals continued. I'll do the best I can. My young son is sleeping, so I'm trying to be quiet. It's nap time. So let me see. And I'll introduce the rules and everything. One of the rules, the main one is a to the m over n. So when you have a base and you have it to an exponent that happens to be a rational expression, it's a fraction, then the a to the m to the over n is the nth root. I have to get warmed up here, of a to the m. What that means is that the denominator, this is called an index. We talked about that in 10.1. And the denominator, the thing you need to remember is the denominator is always the index. And then the other thing is sometimes it helps me to put that m on the outside. I should have written a little smaller. And it's also the nth root of a to the m. So we're going to use whichever way of these two items that works the best for this problem. So when you see something to the power that happens to be a fraction, then you're going to rewrite it in radical notation, because then you can maybe simplify. So 400 to the 1/2 is the square root of 400 to the first. And this is technically, if you don't see it, it's an implied 2, so a square root. So I won't usually write this in there. If you don't see it, it's a 2. So this is the square root of, could you write the 400 as something squared? And then last time we said the nth root of a to the n, meaning if the index matches my exponent, then the a comes out. So this is the rule from 10.1 that we're going to use here. So the index is a 2 and my exponent is a 2. So this simply means the 20 comes out. Or you could just say the square root of 400 is 20. However, I like to use this same reasoning because when you have variables, then you can't just use your calculator. On the next one, it says use radical notation to write the expression. Simplify if possible. Assume that all variables represent non-negative quantities. We're going to assume that for this whole lesson, because if my variables sometimes, if they were a negative quantity, then when you have an index that is even, you're going to have a problem because that causes a not real number. So here, the one thing that's really important here is students often write this as, and I'm going to do it in red because it's incorrect, but students often write this as the 5th root of 4m, for example. This is incorrect because we need to remember what does an exponent affect, and that is, I always like to write this down here. An exponent, this is important for later as well, affects only what it immediately touches. And the book doesn't say it like this, but this is really key. So I want you to remember this. The 4 has its own exponent, and it's really a 4 to the first power. So this 1/5 only touches the m. So if it's not in the parentheses, then the 1/5 only attaches to the m. So it's really 4 times the 5th root of m to the first, which is just m. So that's this in radical notation. And then you cannot simplify that further. That's all this wants, okay? Now I'm going to scroll. And I'm going to try to make this, I'm going slow as if this were class. And then you can pause and play and whatever. And if it gets too long, because there's going to be some coming up that are a little heavier, I will make another video. So we'll see how this goes, okay? I'm playing this by ear. Okay, this is 64x to the 8th quantity square to the half, meaning everything inside is affected by that exponent. So this is like you could write it, you can do this two ways. And I shouldn't even put the 2. Well, I'm gonna go ahead and this is my denominator. The denominator is the index. So you have a 64x to the 8th. Then in 10.1, we already covered this somewhat. You could then say that's the square root of 64 can be written as something squared. And x to the 8th can be written as something squared. And then think about what needs to be here to make that an 8. Power to power, you multiply. So b to the m to the n, or in this book, I think it's an a. This is the old rule. So this would have to be a 4, wouldn't it? 4 times 2 is 8. And then the index matches the exponent, whatever that is, comes out. The index here matches that exponent, whatever that is, comes out. And then we can have a big debate on what you like better. Like x to the 8th. You could have written this separately, like you could have written this as the square root of 64 and the square root of, I'm not going to do that actually, because that doesn't help you. This here, that just turns into this one. Some of you don't like it when I make things more confusing, but you could have written this as a square root of 64 times, and then the x to the 8th to the 1/2. 8 times a half is 4, you see? But then it didn't have a radical anymore. I didn't even use a radical. And here it says use radical notation, so you really should do it like this. Okay, so I shouldn't probably confuse things and make it harder for you. But this is an option. If it didn't tell you to use radical notation, you could deal with that, with it like that. Okay, so the next one, use radical notation to write the expression, simplify if possible. So you're always going to do that, simplify if possible. So let's see what this one looks like. The index is always the denominator. You have a negative 216, and you have that squared. And here, this is the great debate. Do you want to make a huge number? You know, so I'm going to use calculator for 216 squared. There's different ways to do these. So if you don't like the way I'm doing this one, there's another way to do it. But this is a huge number, which I don't like usually. Whoa. 46,656, you see? Sorry. Let me pause and get that with the calculator so you don't have to wait on me. So it's 36 cubed, because 36 times 36 times 36 makes that huge number. And then the index matches the exponent, so the 36 comes out. We can make this, do this a different way. One thing that is important, you're not going to get a negative out, because negative squared, right? Quantity squared is definitely positive. Some of you would like to write it like this. See, this is you can argue and people get mad because they don't like having options, but I cannot help it that this is true. Negative 6 cubed is negative 216. You see this? And then we have this rule. that you can, I had it written down earlier. So a to the m over n is the nth root of a to the m, but you can also put the m on the outside. Meaning, this looks confusing, but really what you need to know is this m here can be inside or outside, and sometimes it helps you to move it to the outside. So what if, and you can also switch them, a to the m to the n is the same thing as a to the n to the m because of that commutative property of multiplication, you see? So anyway, I need to show you some options. I cannot help it that this is the way it turns out. And then the 36 comes out. And then the third way, if you already don't like this, if you use this rule and say, well, here the m can go to the outside, then actually the one I like the best. So I could go back and forth. It really depends on the problem. And see, this is using this rule. I'm going to move that m, this piece, to the outside. And then this here, the threes undo each other really, or you have if the index matches the exponent, what's under there comes out, but as a quantity. And then you have -6 quantity squared is 36. Which way is best? I don't know. It depends on which way you like the best. I just need for you to learn that you can manipulate this around depending on what the problem looks like. You have, when you have variables, you can't use a calculator because it's not going to help you. Here, you could use a calculator like I did in the first way, and you might say, well, why is she doing all this complicated stuff over here? It doesn't matter. And when I have a calculator handy, sure, I can do it this way, no problem. However, a calculator would actually just do this and this, but I need for you to see how it works because then with the x's, we have to maneuver them around and make it work. So there can be some frustration here, and 10-2 is a hard one to teach because there are so many options. On the next one, use radical notation to write the expression. Okay, so it's this whole thing to the 3/4. Remember this. When you have a sum or a difference, you cannot just take the exponent to each one, okay? Now, if you have something times something and you square it times something, you see that's the key, then that's x squared, y squared. You learned that back in polynomials. But this is a binomial squared, and if you remember this, you would have to FOIL this. You can't do that with a 3/4. It's not gonna work. So it says use radical notation. That's why sometimes radical notation is really helpful. In this specific case, all it wants you to do is write it in radical notation. So you can either write it like this, or you can write it like this. Computer should take either one. Now we have a summary of rules, a summary of rules. If m and n are rational numbers, meaning my exponent is a rational number that includes all fractions, all whole numbers, integers, etc., and a and b and c are numbers for which expressions below exist, then, and you already know this, this is chapter 5. So if you had intermediate algebra and you didn't have chapter 5, you might want to revisit this. This is chapter 5. This is chapter 5. You see in this one, I just brought that up, something times something squared. This is a quotient rule. So each one gets the exponent. This one here If you're dividing, you subtract the exponents. If you're multiplying, you add the exponents. A to the 0 is 1. Anything to the 0 power is 1. And this one here, you don't know this yet because we decided to wait. It is in chapter 5, but we decided to wait until chapter 10 to do it. This is one that gets really interesting. So you need to remember this a to the negative n is 1 over a to the n. But then sometimes we get something like this. This is why I use this as an example. I grabbed stuff like this. This isn't as simple. You know, this one here is doable with this rule. 1 over p to the negative 3. This is the opposite of that one. So what I want you to remember is if it has a negative exponent, so if it has a negative exponent, that doesn't make the number negative. You move it. And in class, it's much easier because I just holler, you move it, you know. So if it's downstairs, you move it upstairs. If it's upstairs, you move it downstairs. Do you see how this one here is technically in the numerator? And what you do with it is you move it to the denominator and change that from a negative exponent to a positive exponent. If you have 1 over b to the negative n, then you say, oh, it has a negative exponent. It's downstairs right now, so I'm going to move it upstairs. And if you have something that looks like this, so let's say you have a fraction, this one has a negative exponent, this one has a negative exponent, then you say, oh, well, I have to move this one downstairs and make that exponent positive. And this one here, you're going to say, oh, I'm going to move this one upstairs. And for all of those scenarios, this here works. And what I usually do is I say, if it's, I'm going to look at exponent is an attitude. Students do really well with this. Exponent equals attitude. So let's look at this piece here. If you can see, hopefully you can see where my cursor is, but you see how this one is here. It's technically upstairs, this A. I'm going to say, oh, that's so-and-so. He has a bad attitude. We're going to move him into the basement, and then he straightens up real fast. So if he's downstairs and he has a bad attitude, we're going to move him upstairs, and maybe he'll get a better attitude. So in this case, this first case here, this thing is downstairs. We're going to move it upstairs. And then you technically do not need over the 1, right? The computer won't like it. So 1 over p to the negative third is really p to the third. On this one here, you have to be careful because, and then students look at this rule here, this rule, and they say, oh, you just flip it. And I don't like that terminology because I don't want you to think you just flip it. You don't just flip this one. Do you see how this x down here has its own exponent and it happens to be a 1? So you need to remember that. It does not have a bad attitude. It gets to stay downstairs. Playing in the basement, you know? But this one up here, Xavier, he has a negative exponent upstairs. We're going to move him downstairs. So we leave this guy down here, x to the first, we leave him downstairs. Then we're going to say this guy has a bad attitude upstairs. We're going to move him downstairs. If there's nothing left upstairs, then we can just have to put a 1, right? And then you say, well, what's x to the first times x squared? And you use your old rules, the product rule. So then you're left with 1 over x cubed. Now there's another way to do this one. And again, there's going to be lots of ways to do things, and you can hate me for it. It's not B, it's the material, okay? So what if you wanted to use the rule? Why can't you use the quotient rule, you see? you could use a quotient rule. When you're dividing here, you subtract the exponents. So this, actually, if you used a quotient rule, you'd have an x to the -2 minus 1, which is an x to the -3rd, which is still 1 over x to the 3rd. And just to clarify right here, while I'm doing this, never leave a negative exponent, at least not in this chapter. Never put a negative exponent as final answer. It's going to want you to make that positive, and it'll tell you actually. So you have no choice but to turn that x to the -3rd into 1 over x cubed. Excuse my dog while she coughs. And again, I'm trying to be quiet. My son is taking a nap. So here, again, this is one of the perfect examples. I don't want to use move it. I don't want to use flip it. I want to use move it, you know. So what do I want to move? Well, all of these kids are playing together. Some of them are upstairs, some of them are downstairs. The 7's happy upstairs. He gets to stay. This 7 is unhappy downstairs. So we're going to move it. This A is happy upstairs. This A is unhappy downstairs. So you're going to move it and make it happy. See? That B squared is happy downstairs. If you look at it, so always kind of look at what am I leaving and what am I moving. And that B to the -4th, so this is an unhappy boy, and we're going to make him happy because we're going to put him in the basement to play with this other kid. And then you have numerator, denominator, and factor, cancel, cancel. Nothing factors, nothing cancels. And in this case, it really doesn't matter because you were busy moving stuff. Sometimes you can simplify things in the beginning. So 7 times 7, 49. A to the 4th over B to the 6th. So hopefully this helps. I like these. These are a lot of fun. Once you get this idea of the attitude, that usually really helps instead of memorizing a bunch of rules that look unfamiliar to you. So this one hopefully was better than the last one. The last one was confusing. Right, with positive exponents, simplify if possible. So this is a combo of the last one and the one before. So the first thing you do is a negative exponent never makes a negative number. I'm not saying you can't have a negative number to a negative exponent like in this one, but here you simply say, hey, this is technically upstairs. We're going to put him in the basement. And we're going to straighten out his attitude. See? And then we're going to simplify. So I'm not going to make that an equal sign because this is not an equation. I'm going to arrow over because I didn't leave myself enough space. Now, it's a positive exponent. If it looks like a fraction, I'm going to try to put it into radical notation to make it more manageable. I have no idea yet what this is going to look like, okay? So you have to bear with me. The index is always the denominator. And make sure you put that index inside, not outside. Cubed root of 2 is very different, or cubed root of 8, let's say, is very different from 3 times the square root of 8. You see what I'm saying? This really is 3 times square root of 8. This is really a cubed root of 8, so be careful with this. Okay, cube root of 1,000 to the 5th. Now, if I take 1,000 to the 5th, it's going to be huge. 1,000 times 1,000 times 1,000, etc. So I'm going to do this a little bit different. And again, there's options. So I'm going to split this into 1,000 cubed times 1,000 squared. This is not the only option. This might not even be the best option, okay? This here, the 1,000 comes out, and you still have a cube root of 1,000 squared. Now, I already know where I'm going with this. Actually, I like it. I'm going to put that 2 on the outside. And this is where you may not want to do that yet, or you may end up saying 1,000 squared is manageable. I'm going to deal with it, but I'm going to do it my way this time, and then I might look at other ways. 1,000 is 10 times 10 times 10, so 10 cubed. Yeah, this isn't necessarily the best way. I'll work this a couple different ways. You still have that 1,000 from the beginning that you pulled, and then the threes match, so then you have a 10 squared, and 1,000 times 10 squared does 100, right? And then you have 100,000. Now, if you have a calculator, you might say, well, I wouldn't have done it that way. You know, this is confusing for you. I split them up into something that is even with the index, so I can pull that forward and then I'll look at what's left under here. Maybe not the easiest way to do it. You could, I don't want to make it worse, but I'm going to keep messing with this for another minute. And then I'll scroll. Let me try to move this down if it'll let me. Okay. Change color. I know, bear with me. This isn't always, my first instinct isn't always the best. I don't can this stuff, you know? So this is where we go. We still would definitely go here, and then we would look at it. Can we do this differently? If I look at it that way, a 1,000 is 10 cubed, so this may be better. Okay, so this 1,000 here is a 10 cubed, and so I changed nothing from here to here, except I wrote the 1,000 to the 5th as a 10 cubed, which is the 1,000 to the 5th. Then I use the rule that I can exchange these two. These two, I can exchange them. That's legal. So that's 10 to the 5th cubed, and it's 1 over. Can't forget that that was originally a fraction from here. And then that turns into 1 over. This matches this. So what comes out, 10 to the 5th, which is 10 times 10 times 10 times 10, etc. Oh, and you guess what? I messed up. Oh, I might have to rewind. Do you see this here? But you caught me. I always say I make mistakes because I'm a human being. I catch my mistakes. But do you see how this whole thing here is in the denominator? And I forgot that as I was working on it, on the denominator piece for my final answer, this is not my final answer here. This is just where I messed with the denominator. I caught it, but a little late. So 1 over just the denominator. This is all denominator. This is denominator here. So it's 1 over 100,000. Okay, so then you can check in your calculator and make sure that it's true. So take a second, and if you need help plugging stuff into your calculator, I like to help students in class with that. Might be a little difficult. Bear with me, but you can plug this into. Oh, it doesn't like it. It doesn't like the negative exponent. No, it does it when I do 2 to the negative a third. So I wanted to do 1,000 to the negative 5 divided by 3. Okay, it works. It's in decimal 0.00001, but if you take 1 divided by 100,000, that's 0.00001. Anyway, different ways to fiddle with these exponents. It's important you learn them because we have to use them in a minute on all of our variables, okay? So on a variable, you can't just simply use a calculator. Okay. Yes, it's tedious and you have to be patient today. So this one here is this piece is that thing that has that negative attitude. So this is the piece that we're going to put in the basement. So it can be originally negative, but we're going to give it a positive attitude. And then we can write that as, and the same debate will happen over and over. I'm just getting warmed up. I haven't done this in a while. But cube root of negative 125 squared. And then we can write the 2, we're going to move to the outside. This one's not as bad. And then negative 125, we can change into negative 5 cubed. You see how negative 5 times negative 5 is negative 125. Negative 25 times 5 is negative 125. Now the index matches the exponent, the negative 5 comes out. But it's still taken to the power, and you're left with 1/25. Okay, so that was a little easier. The last one, okay, lots of zeros. Write with positive exponents. This one here is just simply upstairs, downstairs. This thing has a negative attitude attached. It's going to come upstairs. And it's not asking me to put it in radical notation. So that's all it wants, okay? Simplify if possible. Even if you put it in radical notation, nothing would come out, okay? So that means this is simplified. Write with positive exponents. So this is getting a little bit easier now. And I'll put some space between. Okay, this one here, what do you want to be careful with? That negative 1/5 touches what? Only the x. So this is 9/7 stays downstairs. The 9 stays upstairs, and the x to the 1/5. Right? This guy has a bad attitude. We're going to move him upstairs, and he's going to have a good attitude. Or your final answer is this. And I don't mind improper fractions. Please, no mixed numbers right now. I'm not super loud and funny because I'm trying to be quiet, so this is hard. Okay, use the properties of exponents to simplify the expression. Properties of exponents. B to the m times b to the n, or this book uses the a's. Doesn't matter. When you're multiplying, you add your exponents. Whoops. I want to use the b from the problem. You add your exponents. So this is simply d 3/7 plus 8/7. And basic math, add fractions, you go across over the common denominator. This one's pretty cake, huh? Like there were some that were kind of ugly. Okay, let's look at this one. You can do this one 2 ways. You can use, well, it says use the properties of exponents. So if it tells me that, I'm going to go ahead and go for that. When you're multiplying exponents, when you're multiplying and you have the like base, you add your exponents. So this would be using the rule, the product rule. -6 plus 11 is 5, which is x to the first, which is x. The other way you could have done this one is to say, I don't like negative exponents. I'm not saying this is better. It's just sometimes people have different ways of thinking, and that's not wrong. Some people say, well, I don't like that. I'm going to move that into, in this case, this guy has bad attitude. I'm putting him downstairs in the basement. Or this girl has a bad attitude. I one time had a student who got mad at me because he said, you don't like guys because you're always complaining about the guys. I don't care if you're a guy or a girl. So this girl has a bad attitude, so we're gonna move her downstairs. Okay. So then if you use the property of exponents here, when you're dividing, you subtract the exponents. So you see what I'm saying? You end up with x 11 minus 6 is 5. Do you see? It doesn't matter. You're still going to get the same result, same answer. So, but there's different ways to do things, and don't knock them. It's just different. Use the properties of exponents. So this time I'm just going to go with the quotient rule because it's already a division. So I'm going to use the quotient rule immediately. Like base, subtract exponents. Then we have to watch it a little bit. So I'm subtracting exponents, which if I'm subtracting, I have to have a common denominator, right? And it's pretty obvious here. 10 times 2 is 20. 1 times 2 is 2. I know it seems silly, but I have to watch that basic math when I'm talking and working at the same time. 2 minus 1, so it's 1 over 20. And it's not asking me to put it in a radical notation or anything. It just wants me to do this. Okay. So far, I think everything's been pretty clear except for that one that got messy. And we only have, well, we have 3 more. I'm going to go ahead and finish it. Oh, yeah. Properties of exponents. What do you want to do with this? That's the thing. Like in class, I will say, what do you want to do with this? Most students want to fiddle with the numerator first because they're like base and they're just going to add the exponents. So I'm going to do it that way, and then I'll show you that you could have done it a different way. That's b to the 1/5 plus 3/5 all over. Now I'm going to do something here. This is dangerous. Some of you will want to move that up, and I'm all for it, but you need to separate that -1 first because that exponent here does not touch that negative sign. And this isn't necessarily the greatest way to do it. Actually, if I move this guy upstairs first, it might be better. Be open-minded. b to the 4/5 over, and this is now this negative turns this whole thing into a negative. So we're just going to remember this whole thing is now a negative. So we'll move that to the front because we're not supposed to leave a negative in the bottom anyway. And here's your b to the -1/5. Now you can move this guy upstairs and combine them or add the exponents, or you can use the quotient rule. -b, because that's now all negative. The actual thing is negative, not the exponent. 4/5 minus, this is the quotient rule, a to the m over a to the n is a to the m minus n. And I mean, this minus is this minus. But you have to remember when you're using the quotient rule, this is the n piece. So this is probably not the preferable method. I'm not saying it's wrong. The denominator is simply a 1, so it's gone. So then this turns into, I'm going to do it, I think, the easier way. But some of you will prefer this, so I can't say it's worse. This is where people get frustrated with me, and it's really hard to teach this section. because there's so many options. 4/5 plus 1/5 is 5/5. So you're just left with a negative b for a final answer. Okay, let me grab a different pen. I don't know. Everybody's different. If actually in this case, there's two more ways to do this. Arg. I'm going to go ahead and pull this negative forward so it's out of the way because it's not attached. It's not in a parentheses, so whoops, I can't write right here. To the negative 1/5. Okay. If you use the properties of exponents actually and go straight to that, you would actually have negative b to the. These are multiplied. So you're adding. And then you're turning around and subtracting. But then again, this is another one where it's subtracting a negative because you're dividing. Oh, I don't know. I don't know if I want to share this video. It's a struggle, this section. That's 1/5. This is all the exponent, right? Negative b 1/5 plus 3/5 plus 1/5 is 5/5. All right, now I figured out which way I like best. Don't show us so many methods. I'm going to tell you, I'm going to show you a lot of methods because you have to figure out which one works for you. Okay. I'm going to take the original, move the negative forward. That way it's out of the way. And then I'm going to say I have b to the 1/5 times b to the 3/5. And this negative, this guy here, this girl here, her name is Bertha. She has a negative attitude. We're going to move her upstairs and make that positive attitude. Now there is no denominator, so it's simply negative b. And now you have multiplication, and you can say that's 1/5 plus 3/5 plus 1/5. And that is negative b to the 5/5. And then we're back here. You see, it's a struggle. Still, I want to show you options. So if you can do it all three ways, it means you fully understand these rules. So two more. Ugh. I think we're going to pick one. Which one do we want? The one that also has, I think I'm going to pick, this one's not bad. 2 cubed is 8, and then you can take y to the 3/4, and then you can deal with your y. So we're going to do the last one because I want this video to be not forever long. Okay, I do want to give myself space. All right. Now, rules of exponents. This 1/6, this exponent touches that parentheses, so it affects everything inside. So the first thing I'm going to do, I'm positive on this one, which way is best, at least to start it. And then here it says, simplify the given expression, write the answer with positive exponents. So like I said earlier, you can't write the answer with a negative exponent. So y to the 3rd. So do you remember this rule from back when? B to the m to the n is b to the m times n. So we're going to, and everything inside gets that exponent. So it's y to the 3/6. Can we all agree that y to the 3/6 is y to the 1/2? Because I'm simplifying that fraction, yes? So 3 times 1/6 is 1/2. Z to the 1/6 over y to the negative 1/2, z to the 1/3. And then I'm going to switch back. Oops, some people do not like different, the green pen is a little bright. Okay, Now, you can use the exponent rules, but actually I'm going to go ahead and move this guy upstairs. I think that like the last way I did on the last problem might have been best. This is a negative attitude. Yolanda comes upstairs and has a better attitude. And then you have a z to the 1/6 over z to the 1/3. And then you deal with each one individually. Y to the 1/2 times y to the 1/2 is y to the half plus a half, which is just y to the first, isn't it? A half and a half is 1. And then z to the, if you're dividing, you have a 1/6 minus a third. And then we're going to just combine 1/2 and a half is 1, so it's just 1. 1/6 minus a third, so I do that off to the side. Basic math, 3 times 2, 1 times 2, right? Oh no, what happened? We got a negative 1/6. You know what that means. Now for a final answer, we need positive exponents. So he's going to go back, or she, y upstairs and z to the 1/6 downstairs. You can't always tell which way they're going to turn out. I wasn't paying attention to the actual exponents. But that's okay. Double checking my work real quick. So this is one of the hardest lessons to teach because there are options. This is one of the ones where you want to, especially if you get frustrated. I have some students, they're pretty flexible and they don't mind learning different ways. And they're like, okay, I understand this one. I understand this one, but I do prefer this over that one. And then I have students who, they get really frustrated if I show them 2 methods. Oh, this one made sense. Now you're confusing me. I'm not trying to confuse you. I'm simply saying there are different ways to do it. And some of you like one way over the other, and I don't want to ignore you just because someone else doesn't like it. So if you find that annoying, you need to just tune me out. Once you have a method you like, then you just tune out the rest of it. So anyway, thank you for hanging in there. The next one will be easy, I promise. It's just this section is a little bit tough.